Hello, Math 153. This lesson is 12.3, Measures of Dispersion. What that means is we're just measuring how spread apart the data is, if you will. And there's two different kind of terminology for that. And it's going to be, one of those terms is going to be range. The other one is called standard deviation. So we're going to look at how to find both of those things here in this section. So measure of dispersion used to describe the spread of the data. And like I just said, we have two main things that we're looking at here. We're going to look at how to calculate the range of a data set, and then we're also going to look at how to calculate the standard deviation. Now the first one, the range. The range is going to be the easiest one. It's something you may have done before. It's the difference between the highest and the lowest. So you take the highest data value, and you subtract the lowest data value. That's going to give you the range, highest minus lowest. So example 1, computing the range. This figure above, 12.8, shows the age of the 4 oldest US presidents at the start of their first term. Find the age range of the 4 oldest presidents. So what we do here with this one, we can look at the ages that we see at the top of the bar graph. So we have 70 is the oldest, 65 is the lowest here. So again, you have to take the highest and you want to subtract the lowest here. So we want to do 70 minus 65, which gives us a 5. So we say the range is 5 years. There's 5 years between the highest and the lowest. Okay, the next one. Now we're moving on to standard deviation. The standard deviation is again a measure of dispersion, and it's dependent on all of the data items. Whereas range solely focuses on the highest and the lowest. It doesn't matter about anything in between. Now we're focused on what's in between as well. So we're going to use the same chart that we looked at in the first one. So we want to prepare to find the standard deviation. We want to find the deviations from the mean of the 4 data items, which was the 70, 69, 68, and 65 from that figure in 12.8. So again, we're taking those 4 ages. The first thing we need to do is find the mean here. So we want to first add up those 4 ages. And then since there's 4, we want to divide it by 4. And when we add these up, you can follow along with your calculator as I do, just so you can see where all the numbers are coming from. We get 272, and we have to divide that by 4. And when we do that, we get a mean of 68. So again, this is the mean. We can think of that as x bar equals 68, because remember that x bar represents the mean. So now, the second step of finding the standard deviation is find out how much each of the data items differ from the mean. So we want to find how far apart is each of these items, how far are they from the mean. So data item, we're just going to list those 4 data items in this first column here. So 70, 69, 68, and then 65. And again, we want to find out how far away they are from the mean. So we're going to start, and you can see the little formula here, if you will, where we want to take the data item, which is represented by x, and we want to subtract the mean. So for the first one, the data item is 70, and we want to subtract the mean, and we get a value of 2. The next one, the data item is 60. We subtract the mean, we get 1. The next one, we have a data value of 68 minus the mean of 68, which is 0. And the last one, we have to take the data value of 65 minus 68. This is going to give us a negative 3. Now, one thing you should look at is when you do this, if you were to add all those together, the sum of these should always be 0. So we're going to say the sum of all, and we call these the deviations. These are called the deviations. The sum of all the deviations should equal 0. If they do not, then you made a mistake someplace. Okay, so the first step was to find the mean. The second step was to find all the deviations. And you can see that here's all the steps to find the standard deviation, and we've done the first 2 already. Find the mean of the data sets, check, we've done that. Find the deviation, which is the data item minus the mean, check, we've done that step. The next step then, it says square each deviation. So we want to take the data item minus the mean, which we did in the previous step, and now we're going to square that value. And let's go ahead and look at example 3 here. So we want to find the standard deviation for the 4 President's aides. So you can see that I just took the 2 columns that we did in the previous chart and just carried them over here so we have them in front of us. So then what we have to do is we need to take the data item minus the mean and square it here. So since the deviation for the first one was 2, we want to take 2 squared, which gives us 4. The next one, the deviation is 1, square it, that gives us 1. The next one was 0, square it, and that gives us 0. Now we want to be very careful with the next one. We don't want to just write it like this, because if you type that into your calculator just like that, you'll get a -9. Be very careful when we're squaring a negative, we need to keep the negative inside the parentheses, which will give us a value of a +9. If you're getting a negative value there, you forgot your parentheses. So kind of keep that logged in, that you must have a negative inside parentheses, or else it's going to give you that negative. So now we squared each deviation here. So we did that step 3 there. And then step 4 is the sum of the standard deviations, which means we want to add these 4 things together here. So 4 plus 1 is 5, 5 and 9 is 14. So that gives us a 14 here. So this is going to be the sum of the squared deviations. And like I said, this was from step 4. That's from step 4. So step 4, check. So far we've completed the first 4 steps. So it says here steps 1 through 4 have all been completed above. Step 5, divide the sum in step 4, so 14, by n minus 1, where n represents the number of data items here. Well, we know that we're working with 4 ages, so n equals 4 here. So we want to divide the sum in step 4, which would be 14, by n minus 1, which would be 4 minus 1, which would be 14 minus 3. And if you use your calculator to do that, you'll notice that you're getting a repeating decimal. So this is equal to 4.6 repeating. Now, the next step, it's very important that we use the exact value. We do not want to round this 4.6 repeating. We want to use this exact value into this step. So I'm going to say use exact because we're using that in the next one. So this was step 5 when we took the sum and divided it by n minus 1. And then 6, take, it doesn't matter where you read this, I'll say up here, take the square root of the quotient in step 5. This value is what we call the standard deviation. So we take this value right here and we take the square root of that. Now again, we want to make sure we use the exact. So we want to find S represents standard deviation, and we want to divide that by the quotient we found in the previous one, which is 14 over 3. So in your calculator, the square root, so second x squared, gives you the square root, and then 14 divided by 3 gives you a value that is approximately 2.16. That is what we call the standard deviation. So this is the standard deviation of this data set. Again, it's another way to measure the spread in all the data. So you can see that we had these 6 steps here. Now, I'm going to also show you how you can use your calculator to do all of this, which is probably what you'll be more inclined to do. It's good to know how to find that value. That way you know where the calculator is coming from, and you're not just saying, I don't know, it's what the calculator told me. But that's how it's computing it. So going to the next page, or the last page rather, it says, how do you find standard deviation on the calculator? I will create another video just like I did with part 2 of 12.2 on the other app on my iPad here. But for now, I'll just kind of walk you through it and you can kind of follow along. And then if you need to, reference the other video. So it's going to be the one idea here. It's the same steps as finding the mean or median. So it's going to be the same steps as finding the mean or median. So if you need to, you can think back to the other video and just instead of choosing mean or median, you're choosing option 4, which is standard deviation. Okay, so the buttons we have to press here. So keep in mind the first button you want to press is the stat button. So you want to press the stat button first. And then you want to hit either option 1 or enter because you want to edit the first list here. So stat, and then you want to select edit, which is option 1. Now, if you have a list in there, you can just hit the clear button and that'll clear it out. And then what you want to do is type your list in there. So let's go back to the president's ages here. So we have 70, enter, 69, enter, 68, enter, and 65, enter. So again, you're entering all of those into L1 and then go to second quit. So stat edit, then I'm going to say enter data into L1. And then second quit to get out of there. And second quit. Then after we do that, we have to hit second stat. And then you want to go over to the right to the math. And then once you're there, you want to go down to number 7, which is labeled as STD, then with a capital DEV for standard deviation. And when you hit enter, then that'll come back to your home screen and say standard deviation with a parenthesis, then second 1 for L1, second 1, that gives us that L1, and then enter. And that'll give you the same standard deviation that we just found. So go ahead and you can practice that. Actually, I'm probably not going to make another video because it's going to be the same exact steps as what I've done before. So go ahead, practice that. Make sure you can do it on your calculator. So now what we're doing in example 4 is computing the standard deviation. Find the standard deviation of the data items in each of the samples shown below. So what I'm going to have you do is I want you to pause the video and I want you to at least try with sample A for now. We're going to do one and then I'll have you try the other. So I want you to start with sample A. When you're finished with sample A, unpause the video and see how you did in comparison with mine. Okay, first thing, we list all the data items in the first column. Then the second column, you take the data item and subtract the mean. Oh, again, you had to find the mean first, which we found to be 20. So we do 17 minus 20, 18 minus 20, 19 minus 20, and so forth. Keep in mind, when you do this, all of these values here that you found should have a sum of 0, which if you add up all these, you do get a 0. The next step is you want to square the deviation. So you take all those and square them. Again, make sure your negatives have parentheses because we want these to all be positive values. Or else when you go to add them, you'll get a 0 here. And that's going to be kind of confusing to you because then you won't know how to proceed with a 0. We add up all of these, we get a total of 28. Then to find this, the next step was you take the total and you divide it by n minus 1. 7 is our n because that's how many. And then the last step is to take the standard deviation of that. I just kind of did those two in one step. So 28 minus the n minus 1, which is 7 minus 1. So 28 divided by 6, take the square root, you get approximately 2.16. So now what I want you to do, if you haven't yet, go ahead and try sample B. Try to work through that just like we did sample A. So now after you work through this one, again, you find the mean to be 20, which is the same as mean in sample A. So they both have the same mean. However, you notice that their standard deviations are very different. This one has a standard deviation of 10.8, whereas the sample A had a standard deviation of 2.16. Now, I want you to look at the data sets themselves. What could be the underlying cause of why the standard deviations are drastically different? You're right. It's because of the range of the data sets. You can see that the range in sample B is much larger. If you do 30 minus 5, you get 30. So sample B has a range of 30. That means those data items are over a spread of 30 different values. Whereas in sample A, you'll notice that the range here, if you do 23 minus 17, it's only 6 values in there. So these values are packed closely together, which is giving a much smaller standard deviation, where in sample B, the values are spread out a lot more, which is giving a larger standard deviation. All right, example 5, interpreting standard deviation. Two fifth-grade classes have nearly identical mean scores on an aptitude test, but one class has a standard deviation 3 times that of the other. All factors being equal, which class is easier to teach and why? So we need to pause the video, reread the question, give it some thought. Okay, now when we think of this, we can use the example from above as we guide our way through it. Let's think of these as our two classes, sample A being one of the classes, sample B being the other. And you want to say, okay, which one would be easier to teach? Because these ones do have drastically different standard deviations. And we're talking about the aptitude test. So, right, the sample A class, or the ones with the smaller standard deviation, would be easier to teach. We're going to say the class with the smaller standard deviation score, smaller standard deviation score, we say would be easier to teach. Now, why is that going to be? And we're going to think of that as it's going to be easier to teach because all those students are going to be around the same level. Whereas if you have a larger standard deviation, you might have a student that really struggles mixed in with a student that excels really well. But if they have a smaller standard deviation, the students will all be in a similar level. So we can say because the students will be, we can say, similar academically. That would be similar to the idea of a student in Math 005 being placed in the same class as student taking Math 270. You can't put them in the same because they're in totally two different spots. Okay, that's all we have for 12.3. So good luck with this and let me know if you have any questions on the homework. Have a good one. Bye.